Okay, cool. We are recording, so you can see our cool art in the recording as well. So guys, do we remember about circles? We have a diameter and a radius. How do they relate to one another? A diameter and a radius. Guys, remember?
Diameter is like, isn't it like the line through and then the radius is around?
Ooh,
Something?
you're so close. Diameter is the line through. It's the line through the center of the
Yeah.
circle. And you're thinking circumference. Circumference is the distance around a circle. We will definitely be finding that this week. Definitely. What about the radius? So diameter is the whole way through the circle. It's got to hit the center. How does the radius relate to that diameter? You can kind of see it in our picture.
What, the center?
It hits the center. Yeah, it's half of that diameter. Okay, so the radius is half the diameter. That's that relationship. So if the diameter is 12, what would the radius be?
6.
6. Yeah, that's right. No, that's a different number. That is pi. That is the ratio of the circumference to the area of the circle. I gotta say that right. I can't, that doesn't sound right. Okay. So pi definition. It is the circumference divided by its diameter. That's what it is, not the area. Circumference divided by diameter. So, okay. So guys, let's get back on this question. If the radius is 25, what would the diameter be?
50?
12. What?
50. That would be.
Oh, the radius.
Yeah, that would be if it was a diameter. Yeah. That's why I did that, to trick ya. Okay, I don't know why I drew a smiley in there. Why not? If the diameter is 5, what would the radius be?
2.5.
Right.
No, my mic's... Yeah.
2.5. Very good. So radius half that diameter. Wonder if I have, that's probably the best slide I have for the picture. I got to take another picture, guys, and then I'm going to sadly have to clear it off. No. Snip, snip. There you go. Artsy fartsy 3, 4. We're on 4 now. There we go. I've captured your images. I know, it took days. But he says Desmos. That makes him amazing. Sorry, guys. No. Okay. Okay, so we are in week 2 of quarter 4, and you know, we're doing pretty darn awesome, I think. Doing real good there. Today, we're going to do a lot. Today, we're going to talk about I know, right? It's going so fast. Today we will talk about evaluating expressions and how to do that. And we're going to learn how this applies to formulas. We're going to talk about the perimeter formula, the area formula, circumference, and area of a circle. We're also going to talk about changing dimensions. So we'll talk about that related to ratios a little bit. Okay. So let's talk about how to evaluate this expression. Okay, what does it mean to evaluate an expression? What does that tell you to do? That should be like your instructions of what to do. And what does that mean? When it says evaluate this expression, what do you do?
Could be like figure out what the components mean and stuff.
Yes, that's exactly right. That's a part of it. Definitely. Very good. We got to look at the actual expression and kind of figure out what all the components are. I like that. I'm going to write that down. That's good. If you're wondering why I'm typing and using my terrible writing there, yeah, look over. Yeah, look over the components.
It'll be like figure out which ones, like what the lineup is in a way. I forget what it's called.
Okay.
The order of something.
Order of operations?
Yeah.
Okay. Cool. Before we figure out that order of operations or like what you have to do, like right now we really can't do much because it just says 1/2 parentheses B1 plus B2 parentheses H. Yeah. Yeah, unfortunately that's not too exciting, but that's what we got. That's what we got. So what am I going to do if I have the expression and then the components of the expression there? What do I do? You guys see where it says B1 is 3, B2 is 5, H is 6. That's my big hint there. What's up, Mr. Silver? Kitty cat's looking at me. So I'm going to tell you guys what we want to do, and what I want you to write it down is see all these little components of the expression. I love that word. I'm going to overuse it, Vivi. I'm going to overuse it. It's a good word. We're going to replace the variables with their corresponding numbers. And it's whatever they tell you. That's the main thing of what we want to do here. That's what you're going to do with all of these equations today. That's how you evaluate these expressions. We first have to replace the variables with the given corresponding numbers. That's kind of the main process. So what we'll do is here's our 1/2. I gotta kind of piece this together. That's why I'm driving to Minnesota to pick up my computer, because I miss writing on the screen. So what did they tell me B1 was?
3.
3. So instead of B1, I'm going to put a 3. Good. And what about B2?
5.
5. Good. And what did they say H was? 6. Good. Yeah, so what we did is we replaced the variables with the given numbers. That's what we did. And this is actually one of your area formulas. This is your area of a trapezoid formula. So we replaced it with the value of the length of the two bases and then the height. And then from here, it's just doing order of operations. Or if you're not comfortable with that, it's absolutely okay to go to our greatest calculator in the world, Desmos. Abso-fruitly, as Michael Scott would say, abso-fruitly. So we're going to type in 1/2 parentheses. Did it feel wrong? Because it should. No, I'm just kidding. Felt like I shouldn't be using this. It should be Desmos. So if you type it in exactly like how it's written there, you'll get the right answer. It is 24. You could also do your order of operations. Order of operations tells us to do what part first. This is not a sponsored video, right? Parentheses first, yep. So we have to do that 3 plus 5 first. 3 plus 5 is 8. And then, yeah, then the exponents, but we don't really have any exponents. And then when we're left with just multiplication and division, then we kind of do it from left to right. So now we're left with just multiplication and a little division. We would really go left to right. So 1/2 times 8 gives me 4. Half of 8 is 4. Remember, multiplying by 1/2 is the same as dividing by 2. That's what I always think of. And then 4 times 6 is 24. So that's the process today. Lots of picking information out of things and plugging it in. That's all we're doing. Pretty straightforward. Okay, so these are all the area formulas we're going to be using today. You feel free to write it down, but you don't have to. You can very easily Google this stuff. Oh my gosh, it's also awesome. Google is our friend here. You can type in area of a triangle and they have like a calculator that pops right up. It's pretty cool. So area of a triangle is 1/2 times the base times the height. Another way of thinking of it is base times height divided by 2. Base, there you go, times height. I hate writing with my mouse. Divided by 2. That's how I usually calculate it. I think it's a lot easier to take the base times the height and multiply by 2. Area of a rectangle is length times width. Trapezoid is the area thing we just saw. We add the bases together, multiply by the height, and then cut it in half. Parallelogram is base times height. Then there's the area. Oh, pardon my yawn. That's the area of a circle and the circumference right there. Is anybody writing those down where I should not switch? Oh, wait, can't switch yet. Never mind, we gotta do this one. Brave. Oh. Cool. My daughter's washing her hands, counting out loud. She's so good. Okay, so this first one here, this is a rectangle. What would the area of this rectangle be? 40. Yeah, I'm going to take 5. I was going to say, that's right. Don't tell me it's not right. 5 times 8 is 40. And we would label that. How would I label something with area? Squared. Yeah. Yeah, we would say feet squared. Or we would use the little 2. You know, very good. What about perimeter? How would I find the perimeter of that rectangle? Add all of the sides up, right? So what are my sides? 5 plus 8? Right, that's it?
No.
No, what do I add to it?
5.
10 plus 16.
Right. you have to add either what you were going to say, Isaiah, kind of another 5 and another 8, or do what Vivi did and double those sides. So Vivi went 10 plus 16. What do you get either way?
26.
Good job. Oh, sorry. Have not had caffeine yet. Ugh. Sleepy day. Very good. And you don't have to label it squared. Perimeter is just whatever it is, because it's not all the stuff inside. It's around the fence. I always think of the perimeter fence in Jurassic Park. You remember when he's climbing the perimeter fence and it goes, rah, rah. That's what I remember. Okay, down there we have a triangle. So we're going to need a different formula. We're going to need that base times height divided by 2 formula. Oh boy. Working on one computer here. Cut it out. Computer. Okay. So we want to go base times height divided by 2. So what's my base in the triangle down there? What's my base?
4.
4, yep. So I'm
4
going to
something.
take 4 something. They didn't tell us a unit, and that's okay. And what about my height?
I can't see it.
Oh, I didn't know that white box shows up for you guys. Cool. Okay, what's my
9.
height? 9. So 4 times 9, and then we're going to divide by 2. Put my little thing in there.
Wouldn't
Cool.
it be like 18?
Yeah, very good. So 9 times 4 is 36, divided by 2 does give you 18. And you can always write units squared. Keep writing a T in squared. That would say like squirted. Squirted. That's a terrible word. I regret typing it. Okay. So, any questions on that? We're just using the formula and kind of doing what it says there. Use the formula, Luke. All right. So what shape do we, we have a trapezoid. It tells us. Well, that's handy. Super handy. So let's go ahead and do the formula. Easy maths, quick maths. So what would I get if I found the area of this figure? Go ahead, guys, and figure that out. Go ahead and find the areas of this one. So we're going to go 21. Oh, I shouldn't say anything. Quiet chat. Jeez. Ugh, don't make the same mistake I did. Isaiah says 15. What do you guys think? But Isaiah, there is no choice number 15. No, I'm just kidding. I know what you mean. Oh, snap. He's got the area label on there. Go Isaiah. What do you guys think? Do you agree with Isaiah? Here you can bring up.
I don't know. I'm just confused.
Confuzzled.
So what the B1 and the B2 mean now?
Okay, yeah, let's talk about that. What is the B1 and the B2? What is that? I kind of mentioned it before as adding the bases together, the different bases, but how do you know what that is in this figure?
So it's height and the base.
Height and the base. Oh, you didn't use the formula? Fabulous. Oh, did you type it into Google?
No, I did it by myself, but I just didn't use the formula.
Nice. It's all good. It's all good. As long as we get it right all the times. Yeah, so how do we know which ones are the bases? Are we live? Let's make sure I'm not just teaching to Vivi and Isaiah. Let's make sure. Guys, go ahead. Do me a favor. Let's do a little check-in. So go ahead and click on your participant list and click yes. There you go. Arden's there. Click yes on your participant list to indicate you are in fact okay and you are still here. Arden is not here. Oh, okay. Fair enough. What do you guys think? I'm waiting on Lexi and May. Vivi, I know, is here. Okay, so guys, back to my original question there. How do we know which one is base 1 and which one is base 2? What do you think we could do to identify that easily? Yeah, Vivi's not here, right?
It's the height and the base.
Yep, that's what they mean. Height
Would it
and
be
then the
7 yards and 3 yards?
It sure would. How do you know? How do you know that the 7 yards and the 3 yards are our two bases?
Because 7 yards is on the bottom and 3 is going up.
Yeah, but what if our trapezoid was turned on that other 3? Then that other 3 wouldn't be the base. How do we know?
In what direction? Would it look like a box cutter or what?
Yeah, it would be kind of like a box cutter. Yeah.
And then it would be 3, 7 on the long. What is it? It would be the long side because there's still. That's the ultimate height, wouldn't it?
Which one would be the height?
7.
Well, you would think so. But what's tricky with trapezoids is that their bases really don't change because, guys, look at that 7 and that 3. What is true about the lines for the 7 and the 3? What's true about those lines? What type of lines are they?
Oh, they're not
They're right.
diagonal. They're right.
Right angles.
They make right angles, so they have the same angle.
They don't have the weird slanted thing, which makes it easier, I guess, to.
Right. Yeah.
They're not acute or obtuse.
Ooh, good words there, my friend. So what would they ever cross?
Nope,
No.
because they are parallel.
There you go. $1 million word. I love it. Very good.
Braylee said it first, but yeah.
Oh, she did. Oh my gosh, Braylee, I see that. Yep, I see it. Parker, you too. Good job. That goes to my tired zoning out today. Braylee and Parker, you guys were good. You are right. So they are parallel. They totally are. So the bases of trapezoids are parallel.
They do not intersect.
They do not intersect. You are correct. So whenever you're trying to identify what B1 and B2 are, you're just going to pick whichever ones are parallel. That's it.
That makes sense.
Yeah, it helps. Otherwise, there's a lot to choose from. You're right. So the 3 and the 7, so those guys are parallel. So we know that that is our basis. And the other 3 then is left over. And then we still have that 1/2. Oh, I wrote that weird. But 1/2 times 3 plus 7 times 3. And then from then you can go into Desmos, or you can just multiply it out. 3 plus 7 is 10. So we're going 1/2 times 10 times 3. Half of 10 is 5, and 5 times 3 is 15 yards squared. Cool. That is a good one to write down if you are a little bit unsure about that trapezoid formula. It certainly is. Hey, very good. Okay. Questions on that? How would you solve it without the formula?
How do you figure out what the slanted one is?
What you do? It's kind of simple. It probably doesn't work a lot though. What I did was 3 times 3,
Okay.
and that's 9. And then I did 7 minus 3, and that's 4. And then I did, wait, what did I do again? Yeah, 3 times 4, and then I cut that in half.
Okay, so Isaiah, very smart, my friend. Is that what you did, Braylee?
Mhm.
That is confusing. That is so confusing.
So Isaiah, well, he's onto something there. Isaiah visualized it as a square and a triangle, right?
That's smart.
Yeah, very smart. So he figured out that if this side's 3, then this little piece would have to be 4. So he did the area of a triangle plus the area of a square. That also works. Oh, excuse me. That would work, definitely, every time if you did that. And if that is the way that your brain thinks, you go right ahead. Braylee, is that what you were thinking? What you think? Okay. All right. Cool. Oh, I'm too old to handle being up late, I tell you. All right, we got to talk about changing dimensions. This thing always confused me. I don't know why. I feel like it's a interesting thing to explain, and I might show it with a different slide first. Okay, Braylee, yeah, honestly, Braylee, I think the formula is faster, but if you want to do it the way Isaiah did, where you visualized it as a square plus that triangle, I think it would go better. Or it's just a different way of thinking it. Okay, so when we have different figures, okay, like when architects are out there, or when you're trying to build a scale model of something, it's very important to figure out your scale factor. Okay, and you guys talked about scale factor and learned about it that one week that school got kind of canceled. So it might be something that doesn't make a lot of sense. It might be fine, but so you're going to have two shapes, and they're going to say, what is the scale factor? So if we wanted to figure out the scale factor, or how something is scaled down or scaled up, we're just going to compare the sides. Okay? So a scale factor is a ratio. It's a comparison of the two sides between two figures. So for the first one, how do the sides compare? What would my fraction or my ratio be to compare the sides? What do you think between those two figures? What would the fraction be between the sides? Well, what's the length of the long? Yeah. Isaiah, you got it. It's either 9/12 if you compare the small to the big, which you can, or if you go big to small. I always start with whatever's on the left and compare it with what's on the right. That's how I do it. Although, you know, you're not wrong. And Math Excel will tell you which way they want you to structure it. So if we compare the big parallelogram to the small parallelogram, then you get a ratio. Oops, that's not what I meant to do. The big parallelogram side is 12. And the small parallelogram is 9. Cool. So you get 12 over 9. Or if you did it Isaiah's way, you get 9 over 12. It's very good. What does that reduce to? What do both of those divide by? And I always go left to right because my brain says, oh, you started with a big one and then it got smaller. That's what I think. So three.
I just thought with like a fraction, I didn't want it to be whatever that word is.
I got it. Improper.
Yeah.
Yeah, no, you're right. Very good. So Parker, you were right. We divide by 3, we get 4 centimeters over 9 centimeters. So that would be the scale factor. So if they ask you for the scale factor, you're just comparing the two sides and then reducing that fraction. Okay, now it's also going to say what would the ratio of the perimeters be? And that means if you were to find the perimeter, how would the perimeters compare if you also did big to small? And there's a rule in math that tells us it would be exactly the same as the scale factor. So the ratio of perimeter is going to be the same as the scale factor. So that also is 4/3. But the way the areas compare, it's really interesting because this is what these mathematicians found is they did all these experiments and then they found that they all have these same comparisons. The areas compare, you have to square the perimeter and the scale factor. So we're going to go 4 and we're going to raise that to the second power. So square it. And then 3 squared. That's how area works because area is always something that's squared. So what's 4 squared or 4 times 4?
16.
Right, we definitely have 16. And then what about 3 squared?
9.
9. Very good. So the way that the areas would compare is 16 over 9. So that's what kind of you have to do in the homework. They're going to say, okay, if these are your figures, find the scale factor, find this ratio, find that ratio. So the only thing you got to remember is when you have a ratio of area, it's always squared. So you'll either have to square something or square root it to work backwards. So questions on that? We're going to do another example. Okay. Here we go. So this one says, find the scale factor and ratio of perimeters with a pair of similar trapezoids with areas of 25 centimeters squared and 4 centimeters squared. So we have 25 centimeters and then 4. So now this is an area one. So that means that the original scale factor and the original perimeter ratio was squared. So how would I work backwards to figure out what they squared in order to get that? because I got to work backwards so I can get a scale factor. Oh, you guys. How do we work backwards to figure out that scale factor? What is the way of canceling out something that is squared? You guys remember? It looks like this. What is that thingy?
Dividing.
Ratio.
Yeah, you guys are both close.
It looks like a division thing.
It looks like a division thing. It's actually a square root, right? That's a way that you can figure out what was squared to give you that number. So if we start with area, you got to do the square root to get back to the scale factor. The square root of 25, what was squared to give us 25? What was squared?
5.
5, very good. So 5 was squared to give you 25. So we have 5 centimeters. And then what was squared to give you 4?
2.
2. Yeah. So then this 5 over 2 is your scale factor and is your ratio of perimeters. So all you got to do is square root the ratio that they gave us, and then that'll get you back to before you squared. Does that make sense? Friends and neighbors? Okay, let me know if it does it. All right, now, yeah, that brings us right to 10:50. The way it worked out yesterday, I made a video of all this circle stuff. Would you prefer to just watch the video that I put on Moodle? Okay, yeah, so go ahead and watch the video of the circle stuff. And yeah, you guys are free to go.
All right, bye.
It's on the Moodle page. It's not on there yet. I recorded it yesterday, so I'm going to throw it on there right now.
Okay.
So
Thank
yeah,
you.
you're welcome, guys. Have a great day.
You too. Bye.
Bye. Thanks for coming. Bye. Jackson and May, can I help you with anything?